Okay, in the last lesson, we introduced the sum and difference identities for both cosine and sine. The one thing we didn't get to in that video was the tangent of a sum and difference, so we're going to look at that in this video. But before we start, we are going to do one last proof with the sine and cosine one, just to continue to see how this. So when I'm asked to prove this example, first I notice that even though it's ugly, I see cosine, cosine, sine, sine, and then I would sine. And so this is the cosine of a sum. So especially since these angles match and these angles match, so you do have to make sure those angles alternate as well. So I can write this as cosine of the first angle, x plus y. Since this was a plus, I need to change it to subtraction, and then the other angle was y. Once I have that, I see that the y's cancel, and I'm left with cosine of x, which is what I was going for. So you can see there's multiple different ways between this and the couple of examples we did in the last lesson. In terms of how to use this for both proofs, but also simplifying and evaluating things. Okay, so the one thing that we have not done yet is the tangent of a sum and difference. And this one, unfortunately, doesn't have a fun sum that goes with it. And there's also multiple different things, okay? So the first one is that if you ever have the tangent of a sum or difference, and just so you know, this notation I know is a little bit confusing, but you can see that, let me see if I can get a highlighter. If the plus is on top here and it stays on top, that means that it's a plus situation. Whereas the minus on the bottom tells me that those are minuses, and you can see that it's minus here, but you can see that the minus switches to a plus on the bottom. Okay, I forgot to do this one. So a plus here switches to a minus. So it's kind of a confusing notation, but whatever is on top is consistent, whatever is on bottom is consistent. So you can see that the first option is you can change your tangent into sine over cosine and then use the sine and cosine tree that we've been working on yesterday. Or we have a new one that says it is the same as tan u plus tan v over 1 minus tan u tan v. Okay, so again, if we focus on those notations, if it's a plus in my original problem, the sign stays the same on top and it switches on the bottom. That's how I remember it. So tan u plus tan v is the same as tan u plus tan v or 1 minus tan u tan v. If you, however, had tangent of u minus v, it's tan u minus tan v over 1 plus tan u times. Okay, so whether you want to just keep it in tangents or switch to sines, it just kind of depends on the problem. And then there will also be times where you have to switch it. We'll talk about that as well. Okay, so that is our last tool for this part of the lesson. But now we can see that we can use this to prove it. So the tangent of I tried to do this using tangents. Okay, so we said that there's two different ways. So if I take that left-hand side, tangent of pi over 2 minus u, okay, I need to be cotangent. I would do tan u minus tan v, so tan pi over 2 minus tan u over 1 plus, which is sine, tangent pi over 2, tangent of u. Okay? Now, tangent of pi over 2, if you think about that on the unit circle, is 0, 1, but it's sine over cosine, which means that it's actually 1 over 0. Which means it's undefined. So the reason I can't use the tangents in this case is because it's actually undefined there. Okay, so in this example, I so first I minus u over cosine pi over 2. Now, a lot of times I've done my proof straight down. This one I'm going to actually work left to right, and I just need my last step. So I use sine, cosine, cosine, sine on the top. It goes from a minus, so it stays minus, and then I alternate my angles, pi over 2u, pi over 2u. All over the cosine here is cosine, cosine, sine, sine, and then the third sign says switch it from a minus to a plus. Alternate my angles. All right, I'm going to work down from here. Sine of pi over 2 we already said is 1, so we have 1 times cosine u minus cosine pi over 2 is 0 times sine of u over cosine we said is 0. cosine u minus 1 times sine u. So the zeros go away. I'm left with cosine u over sine over sine. That's my problem right there. Over sine u, which is cotangent, which is what I wanted. So you can see that I was able to catch a mistake that I made along the way because I'm always looking back. I wanted positive cotangent, and I had to figure out why I would have ended up with it. Okay, so that was the last example. I just wanted to show you that we also have this tangent of a sum difference, and so you would want to be able to use that as well. All right, so now you have all of the information that you need for assignment number 4. You could have done most of it from the last lesson, but now you can go back and finish. Good day.